All right, today we are going to go through the unit review together. Let's take a look at these vocab words. A blank is a solid figure that's made up of two or more solids. Ooh, if it has two or more, that's the composite solid figure. All right, next one. The space occupied by a three-dimensional figure or solid figure. Ooh, it's the space occupied by it. That's the volume, the amount of space. Volume. A cube with edge lengths of 1 unit. Ooh, if every part of that has 1 unit, that is going to be a unit cube. Unit cube. A blank is a unit for measuring volume. Well, formula, cubic unit, rectangular prism. This is the only one that's a unit, so this is a cubic unit. A blank is an equation that describes the relationship between two or more quantities. Think about this, an equation. An equation is going to be something like length times width times height, or base times height, and that's going to be one of our formulas. So a formula is an equation. Okay. A three-dimensional figure with 6 rectangular faces. All right, we know that that is going to be our rectangular prism. Rectangular prism. Sweet. Okay, let's get into the math. Number 7, which rectangular prisms have a volume of 36 cubic units? And it's a select all that apply. So I always get my length times width times height. This is 5 units by 1, ooh, this is hard to see, 1, 2, 3, 4, 5, 6, and it's 2 high. So 5 times 6 times 2. If we put that into our calculator, that gives us 60 for this one, so it's not A. We're looking for something that's 36 cubic units. This has a length of 3, width of 4, height of 3. So I'm going to do 3 times 3 times 4. Ooh, that gives us 36. So B is definitely one of them. All right, length is 3, width is 6, height is 3. So on our calculator, we do 3 times 6 times 3. And that gives us 54. No good. We're looking for 36. Okay, this is 2 by 3. 1, 2, 3, 4, 5, 6 high. So 2 times 3 times 6 gives us 36 cubic units. That one's a good one. All right, length 1, 2, 3, 4, 5, 6, 7, 8, 9 by 2 by 2. So let's try this one. 9 times 2 times 2. That gives us 36. That's another good 36 cubic unit volume. So B, D, and E. The figure shows a rectangular prism partially filled with unit cubes. What's the volume of the rectangular prism? Well, I know that I can do length times width times height. And the length is 1, 2, 3, 4, 5. The width is 3, and the height is 4. So on my calculator, 5 times 3 times 4 is 60 cubic units. All right, let's go up to number 9. Which equation represents the different ways to find volume of these figures? Okay, so I know that I can do length times width times height. Or I could do base times height. So for this one, length times width times height would be 3 times 4 times 2. Base times height would be, base is 3 times 4. So 3 times 4 is 12, times 2 would be the height. All right, so to get 12, I did 3 times 4. Now, the reason why I'm thinking of it that way is because I looked down here and I saw that they had these parentheses to get the base. So I'm going to circle this and I'm going to circle this. That's for prism A. Which equation represents the different ways to find volume? Now, prism B is the same thing. So if I do, let's see where there's 3 times 4 times 2. Look at this, 3 times 4 times 2. Ooh, that has a plus. It's not going to be that one. We don't want a plus. Ooh, look at this, has all multiplying. 4 times 3 times 2. That was kind of like what we did here. Remember, when you multiply, you can put things out of order, though, that commutative property. So that's good. And then 4 times 3 times 2, that just mixes the 3 times the 2 together and then multiplies the 4. This would be a good one. Now look at this one. 3 times 4 times 2, that's good, but this has too much. 3 times 4 times 3 times 2, so that's not good. And this has adding, so we know that, and the 4, yuck. So it's just A. A rectangular pool is 42 feet long, 15 feet wide, and 4 feet high. It is filled with water to a depth of 3 feet. What is the volume of water in the pool? Okay, so let's talk about this here. We've got a pool that's 15 feet wide. It's 4 feet high, but it's only filled with water to a depth of 3 feet. What is the volume of water in the pool? So we don't care about the 4. We want to know how much water is it. So I know that length times 15, the width, times 3, the height, is going to get us, oh, look, 42 feet long. It told us the length. 42 feet long, 15 feet wide, and it's 3 feet deep. So we just need to do 42 times 15 times 3. Man, it was easier than I thought. 42 times 15 times 3. This is going to be a big number. 1,890 cubic feet. 1,890 right there, D. Awesome. Okay, number 11. The volume of the rectangular prism is 48 cubic inches. What could the dimensions be? So I need my length times width times height to equal 48. Let's see if this first one works. Length is 24 times 1 for width times 2 for height is 48. That one would work. All right, let's try the next one. 6 times 6 times 4. Nope, 144. Next one, 16 times 16 times 16. That's going to be way too much. Sorry, it messed it up. 16 times, no, we're in trouble. I'm turning it off, turning it back on. 16 times 16 times 16. Way too much. 12 times 2 times 2. I think that's going to be too much too. Well, maybe not. 12 times 2 is 24 times 2 more is 48. So that one's another good one, A and D. All right, number 12. What is the volume of this figure? Ooh, we have a composite figure. I'm going to split it right here. So I've got to find length times width times height of this guy. And then over here, I need length times width times height. And then I'm going to add them together. This one plus this one. So we have 3 by, how wide is this? 2 wide. And then 2 tall. So it's 3 times 2 times 2. And then this rectangular prism is 4 for the length, 2 for the width, 3 for the height. So the first one, 3 times 2 times 2, is 12. I'm going to put that down here, 12 cubic units. And the next one, 4 times 2 times 3, is 24 cubic units. And when we add them together, 4, 5, 6, we get 36 cubic units. All right, here's another composite figure. So this is plans for a warehouse. What will be the volume of the warehouse? I'm going to split it right here, and we'll find this one, length times width times height, and this one, and then we'll add them together. So I need to find this length here. The whole thing is 60. Look at this much is 20. So to get 60, I would need 40 here plus 20 is 60. So my length is 40 times my width. How wide is this? Let's see. Oh, there it is. 50 feet wide. And then the height of this, look at that, is 54. So that side of the warehouse is 40 times 50 times 54. Holy moly. 108,000. 108,000. Now this one, length, see that? 20 times width is 50 times height. Well, look at this. This whole thing's 54. This much is 24. So 24 plus this much is 54. 24, 34, 44, 54. This must be 30 feet high. 30 plus 24 is 54. So I'm going to multiply 20 times 50 times 30, and that's 30,000. So now I need to add these two together. 108,000 plus 30,000 to get the whole thing. 138,000 cubic feet. Number 14. The combined volume of two boxes shown is 270 cubic inches. Box A and box B have the same width and height. Box B has twice the volume of box A. Fill in the height and volume of each box. So we know that these two together, A plus B, volume of A plus volume of B, is 270 cubic inches. They have the same width, so they both have 6 for the width. Length times width times height. They both have 6. And they both have the same height. We don't know what the height is. But we do know that box A has a 3-inch length and box B has a 6-inch length. So box B has twice the volume of box A. So 3 times 16, we know that box A is going to be something that's 18 times something. And box B, 6 times 6 is 36 times something. And it's going to give us, where box B has twice the amount of volume as box A. It says fill in the height and volume of each box. So those are the two things we don't know yet. What I'm thinking is this: 36 divided by 2 is 18. So 18 is half of 36. What if we did 270 is the total. So if this was, what are we trying to find out? The height, and they're the same. They're the same. So let's just say, what if it was 2? 18 times 2 is 36 for that volume. 36 times 2 is 72 for volume of B, but 36 plus 72 does not equal 270. So you could try 3 if the height was 3. 18 times 3 is 54. 36 times, oops, I gotta clear that. 36 times 3, oh no, Got to clear it again. 36 times 3 equals 108. Uh-oh, we're getting closer. Let's try, we're not getting close enough. Let's try, let me see, we tried 2, we tried 3. Let's skip, let's try 6. 18 times 6 for the height is 108. And 36 times 6 is 216. Now that's going to be too much. 8, 9, 10, 11, 12, 13, 14. Darn it. So now let's go back to 5. Let's try if the height was 5. So this would be 18 times 5 is 90. And then 36 times 5 is 180. Oh my gosh, I think we might have it. Yay! So if the height was 5 inches, then the volume of A would be 90, the volume of B would be 180, and they would total 270. Ooh, so the process we used for that was guess and check. Okay, next. So this is our last page here. We have a performance task. An ocean engineer places cube-shaped crates on a ship as shown in this figure. One student saw the boxes and said that the figure has a volume of 7 cubic units. Is the student correct? Explain your thinking. Well, let's look. If you just counted the cubes, 1, 2, 3, 4, 5, 6, 7, and then down here, there would be 3 more hidden. So 7, 8, 9, 10. I'm thinking it's 10 cubic units, not 7. Now we could also, so we could say, you know, just counting the cubes, you get 10 and not 7. We could also say that if you decompose this figure, you've got 1 unit cube here. And then this base layer, 1, 2, 3, 4, 5, 6, with the 3 in the back, would be 6. And then this top layer would be 3. So 6 plus 3 plus 1, 6, 7, 8, 9, 10 would equal 10. I feel like the best way to explain this is to say that he was probably forgetting those 3 in the back. If he was just counting 1, 2, 3, 4, 5, 6, 7, he was probably missing those 3 in the back. So when we explain our thinking, we're going to want to explain that when you're counting the cubes, you have to remember that sometimes you don't always see the cubes. There are some hidden in the back that other ones were stacked on. So it says, is the student correct? Explain your thinking. The student is not correct. And I'm going to say how in order for the top 3 cubes to stack up, they must be on top of 3 bottom cubes that we can't see. Well, we can't fully see because you can see that one right there in the picture. The student likely did not count those bottom 3 cubes. So I'm going to put, there's 1, 2, 3, 4, 5, 6, 7. 7 cubes on base plus 3 cubes on top equals 10 cubic units. So the student is not correct. In order for the top 3 cubes to stack up, they must be on top of 3 bottom cubes that we can't fully see in the picture. The student likely did not count those bottom 3 cubes. So 7 cubes on base plus 3 cubes on top equals 10. Part B, The ocean engineer adds more crates so that the figure becomes a rectangular prism that has a length of 3 units, a width of 3 units, and a height of 2 units. How many more crates does the ocean engineer add? Show your work and explain your answer. So if he makes this a full rectangular prism, and he's going to have a 3 by 3 by 2. So length times width times height. 3 times 3 is 9. 9 times 2 is 18 cubic units. So if the whole thing is 18, and we used to have only 10, then how many did he add? 10 plus the mystery number equals 18. Or we could say, so I know 10 plus 8 equals 18, or 18 minus 10 equals 8. So in the end, the answer is he needs to add 8 more crates. And we need to explain our answer. So the engineer needs to add 8 more crates to fill a rectangular prism that is 3 by 3 by 2, or a total of 18 cubic units. He already had 10 cubic units, and 10 plus 8 would fill 18 cubic units. The engineer needs to add 8 more crates to fill a rectangular prism that is 3 by 2 by 2, or a total of 18 cubic units. He already had 10 cubic units, and 10 plus 8 would fill the 18 cubic units. Describe 2 ways to determine the volume of rectangular prisms. So our 2 formulas were length times width times height, or base times height. So when you explain this, you're going to want to explain these 2 formulas in words. So let's do this one. One way to find volume of a rectangular prism is to multiply the length times width times height. Another way is to find the area of the base, and in parentheses I'll put length times width, and then multiply that by the height. So one way to find the volume of a rectangular prism is to multiply the length times width times height. Another way is to find the area of the base, length times width, and then multiply that by the height. Awesome.